First of all, let me congratulate you all on National Science Day. We have been given this opportunity to celebrate National Science Day, and this day is very special for all of us because the first Nobel recipient in physics from India was Dr. C.V. Raman. And due to his discovery on this day, that is on 28 February 1928, he got Nobel Prize in 1930. So his discovery was named to honor him, and it was known as Raman scattering effect. What was his discovery? He discovered while coming back from England to India, he was in a ship, and from the ship he saw the blue color of the sky. And immediately when blue color of the sky, it was already told by Rayleigh, that was the British scientist. He told sky appears blue in color due to scattering. He immediately observed the blue color of the seawater. Then it was explained by Rayleigh, the blue color of the seawater is due to the reflection of the sky in seawater. So according to C.V. Raman, the Rayleigh could not explain it entirely correct. He told, and his discovery, which was known as Rayleigh scattering, which was known as Raman scattering effect, he told when light is incident on a particle, means when it travels through a medium, suppose this is the wave of light whose frequency and wavelength is suppose this much, though this is not ray of light, but I am trying to make it clear. So according to Rayleigh, the light after passing through this medium, its wavelength and frequency remain same. But according to Raman, Professor Raman told there are three phenomena which take place. Number one, according to Rayleigh, one type of waves whose frequency and wavelength does not change. Another, whose wavelength increases, frequency decreases. Such type of lines was reported by Raman as the Stokes lines. And another types of lines whose frequency is increased, you can see in comparison to it, its frequency is increased in comparison to incident ray, and wavelength is decreased. These lines were reported by him as the anti-Stokes lines. And then he entirely told the blue color of the seawater is not due to the reflection of the sky, but it is due to the scattering of light by the particles of the sea. And this day becomes very special for all of us, for all Indians, because due to his discovery, he became the first Nobel Prize winner in physics from India in 1992. Pay your attention. We all have seen while purchasing the electric bulbs, something is written on the bulbs, like you have seen 100 watt, 220 volt, okay, like 60 watt, 220 volt. These are the ratings done on each and every electric appliances. Here suppose this is written 100 watt, 220 volt. It means the power of the bulb is 100 watt and the potential difference across its ends is 220 volt. So one formula we know, P equal to V square upon R, and with the help of this formula, if we are going to calculate what should be the resistance of the filament of this one. So with this formula I can calculate R equal to V square upon P. So V means 220, again multiplied by 220 divided by 100. So answer comes out to be 484 ohm. But is it true? Its resistance of this filament is 200, resistance of this filament is 484 ohm. I am going to check it now. So with the help of this multimeter we are going to check the resistance of this filament of the bulb. You can see now it comes out to be only 35 ohm. Can see. So what is wrong with us? Either the company has not written it correctly or we are somewhere misleading. So the thing is that this is the resistance of the filament of this bulb which comes out to be 484 theoretically, but when we are going to measure it comes out to be only 35 ohm. The reason behind it is this 484 ohm is the resistance of the filament of the bulb. When this bulb is operating, means when this filament gets heated up, at that time its resistance when you will measure, it will certainly be 484 ohm. So these are many phenomena in our day-to-day life which can be discussed on this day, National Science Day. Thank you.